Hi everybody and welcome back for the task 3.3 video. In today's task, we have one learning target that we're going to be working on. Today we are going to be working on identifying the intercepts and the maximums and minimums of a graph and interpreting them in the context of a problem. When we are describing the location of a point on a graph, we do something called a coordinate pair. So this is called an ordered pair or a coordinate pair. The x coordinate is always first. And the y coordinate is always second in an ordered pair. I think about this usually as just being alphabetical order. If you were to say the ABCs or the XYZs at the end, you would say X first, then Y. And it's the same thing when we're listing the points on a graph. We write the X coordinate first and the Y coordinate second. Now, when we're looking at these graphs, these are going to be 4 specific points or locations on a graph that we need to identify. The first specific point that we need to be able to identify are what are called the x-intercepts. These are going to be the point or points where a graph crosses the x-axis. So let's use this graph as an example. I can see that there are 2 places where this graph crosses the x-axis. The first place is right here when x is -4 and the y value is 0. So the ordered pair would be -4, 0. Now for ordered pairs for points, we always use parentheses. This is not an interval. We don't need to worry about brackets versus parentheses. We always use parentheses for points. I should probably have mentioned that earlier. I apologize. So we're not talking about intervals, we're talking about like points, locations on a graph, one spot. The second x-intercept would be when x is -1 and the y is 0. So there are 2 x-intercepts on this graph, -1, 0 and -4, 0. Now the y-intercept is going to be the place, the point on the graph where the graph crosses the y-axis. So on this graph, that would be right here. It's where the graph crosses the y-axis. Now that point would be the point 0, 3, because the x-coordinate here is 0, the y-coordinate is 3. And remember, it's always alphabetical order, x, then y, when we're listing points. Now for a maximum, what we're looking for is the highest point on the graph. In this case, the highest point on the graph would be right here. So we would say that this graph has a maximum value of 5 because that's the highest it goes at, and now we need to say where that happens, and that would happen at -6. I should probably say x equals -6. There we go. When you're listing your maximum, instead of just listing the ordered pair, you need to say it almost like a sentence. It has a maximum of 5, that's the highest it goes, at x equals -6. Now for our minimum, we're going to be looking for the lowest point on the graph. In this case, the lowest point would be right here. So we would say that this graph has a minimum, I like to abbreviate that min, of, in this case, it would be -5. That's the lowest it goes. And then we would say at whatever x coordinate is associated with that point, which in this case would be -2. And that's how we list maximums and minimums. All right, let's try this a few times just to make sure we can find these 4 points on a graph. One of the things I want to make sure you guys really pay attention to is whether the graph has arrows or not. Just like with domain and range and x and increasing and decreasing and constant, that's going to be really important for x-intercepts, y-intercepts, maximums, and mins. So let's start with just x-intercepts first. The x-intercepts are the places on the graph where the graph crosses the x-axis. So that's going to happen right here at -5, right here at -1, right here at +1, and right here at +5. There's going to be 4 of them. That means that I need to list 4 points. So -5, 0, -1, 0, 1, 0, and 5, 0 would be my 4 x-intercepts. My y-intercepts are going to be the places where the graph crosses the y-axis, and there's only going to be one of those on this graph right here, which is going to be the point 0, -1. The maximum is going to be the highest the graph goes. So in this case, the highest the graph goes actually happens in 2 spots, right here and right here. So we're going to have a maximum of the highest it goes is 3 at, and this is going to happen in 2 places, at x equals -2 and x equals +2. So this happens in 2 places. The minimum is going to be the lowest the graph goes. So in this case, the lowest the graph goes is right here, and that's going to be a minimum of -2 at x equals -7. That's the x coordinate. Okay, let's go ahead and try the next problem. Now on the next problem, before I start, I'm going to pay attention to where the arrows are. In this problem, there's an arrow pointing down and going this way. So what that means is when I'm looking for my minimum here, I'm not going to have any. There's never going to be a place that's the lowest the graph goes because the graph keeps going down forever. So when I get to minimum, that's going to be really important. I like to make sure that I kind of focus on that before I start the problem so I don't miss it later on. For x-intercepts, I'm looking for the places where the graph crosses the x-axis. So that's going to be right here and right here. Now you'll notice that this time the graph does not cross the x-axis at nice points. When that happens, it's totally okay to kind of estimate. These points look to be about halfway in between the nice integer values. So I'm going to say that the first one is about -7.5, 0, and the next one's going to be about 5.5, 0. And again, it's okay to just estimate that. It doesn't have to be perfect, just a good guess, somewhere between 5 and 6, somewhere between -7 and -8. For the y-intercept, we're looking for where the graph crosses the y-axis, which would be right here at the +5. So this would be the point 0, 5. For our maximum, we're looking for the highest point on the graph. Now in this case, the highest point on the graph is right here. So the maximum value is 6. I like to abbreviate that max of 6 at, in this case, the x coordinate, the x location is x equals 1. And for the minimum, we're looking for the lowest the graph goes. Because the graph keeps going down, down, down forever, there's going to be no minimum on this graph. I should label this graph up here. Maximum. And let's go back and label that first graph just to make sure if you're ever looking back at your notes, you remember. This is where the maximum, this is where we found that. And this is where we found the minimum. Okay. All right, let's take a look at one last problem. Again, I like to start by looking for the arrows. In this case, there's an arrow pointing up, which means there's going to be no maximum because the graph keeps going up, up, up forever. So when I get to the part of the problem that asks me about the maximum, that's going to be really important. The next thing I'm going to do is find the x-intercepts. Now, the x-intercepts would be the place where the graph crosses the x-axis. In this case, there are no points where the graph crosses the x-axis. So we would say that there are no x-intercepts in this graph. The y-intercepts are going to be the places where the graph crosses the y-axis. Now on this graph, there's going to be one y-intercept at the point 0, 4. Now we already looked at the graph and we said there was no maximum because there's an arrow. So the graph keeps going up, up, up forever. However, there is a minimum. The lowest that the graph goes here is going to be right here. So since the lowest the graph goes is right here, we would say there's a minimum of 1. At, and it looks like the x coordinate here would be 4. All right, now, just like in our other videos, the last thing we're going to follow up with here is interpreting the meaning in the context of the problem. So again, the guidelines here that I would suggest that you follow is that you label the axes if they're not already labeled for you, and then make sure that you state the meaning, so is it a distance, is it a time, or whatever, of the x values using units, and make sure that you state the meaning of the y values using units. Problem number 4 says, Josh leaves home and goes on a drive. The x-axis represents time in minutes. So since the x-axis represents time in minutes, I'm going to label this as time in minutes. And the y-axis represents the distance in miles. So on the y-axis here, I'm going to write distance in miles. So all my y values here are going to be distances. Just like on our other examples, we're going to figure out if we're true or false, and if our answer is true, then we're going to go ahead and say the meaning. So one x-intercept is 18, 0. So let's find the point 18, 0. 18, 0 would be right here, which is indeed a place where the graph crosses the x-axis. So this is true. Now in this case, that is a time. So this tells us that the time is 18 when the distance is 0. So for our answer here, we need to make sure to state the meaning of the 18 as well as the 0. So we would say when the time is 18, minutes, the distance is 0 miles. So you're saying what does the 18 mean and what does the 0 mean, that point on the graph. Problem number 2 here says f of x has a minimum value of 4. So for minimum, we're looking for the lowest point. It looks to me like the lowest point here is actually 0. So this is going to be false because the lowest it goes is not 4. Like 4 would be up here. The graph definitely goes below there. F of x has a maximum value of 6. Now, maximum means the highest it goes of 6. So the highest it goes, it looks like, is 6. Now, 6 is a y value. So we would say that this is true, and that means 6 is a distance. So we would say the maximum distance is 6 miles. And that is the end of the video for today. Thank you guys so much for watching, and I'll see you soon for some practice.